Hi, my name is Gregory Blatt. I'm one of the co-founders of H55. I'm also the mission director for Across America. I'll come back to Across America in a second. Let me tell you a little bit about H55. H55 is the technological legacy of Solar Impulse. Solar Impulse was an electric airplane powered by energy from the sun, so in essence a hybrid airplane, that flew around the world in 2015, 2016. The airplane covered 48,000 kilometers with one pilot on board. We did flights that lasted anywhere from 1 to 5 days. We have one of the co-founders, Andre Borschberg, holds the record for the longest solo flight in the history of mankind, and it was done on renewable energy. So what we understood in Solar Impulse was not a commercial project. It was really to show what was possible with technologies at that time in terms of renewable energy and clean technologies. Now, you can't cheat with an airplane. It either flies or it falls out of the sky. It didn't fall out of the sky in our case. We went around the world with the airplane. Then we realized the efficiency of these electric propulsion systems. And that's where we had the idea of creating H55. So Andre Borschberg, Sebastian Dumont, who was the CTO at Solar Impulse, and myself, we created H55, which builds, designs, certifies, and produces certified electric propulsion systems. What is an electric propulsion system? Electric propulsion system is the motor on one side, the whole drivetrain, the gearbox, the propeller. On the other side is the power and energy management, and the middle, it's the batteries. What used to be called gas, now it's in batteries. And that whole system is the electric propulsion system. We build these systems for OEMs, for airplane manufacturers, for operators, and for component manufacturers. And we have different type of applications with different types of clients in Canada, in the United States, and in Europe. What we're seeing behind me is the B23 Enerique. It's a two-seater general aviation flight trainer. BRM, the manufacturer, based in Czechoslovakia, produces about 150 of these airplanes, mostly to flight schools and general aviation centers. And we do the electric version of this. The B23 combustion is in the process of finalizing its certification in the United States, and we will follow in the United States in about a year and a half. We have to remember that we're starting with a new technology, right? So this is, as we certify in the same process, we're educating the regulators about this new technology, which is actually great because it brings us very close together. And what's also great is that we have, although the approach may be different on how they certify it, there's a lot of cooperation, exchanges, sharing of knowledge between the FAA and EASA and Transport Canada as well. As a matter of fact, H55 has been invited on several occasions by the FAA to do white papers to explain the differences in approaches on certification. Where are we? We will have all our qualified testing done on our batteries by this summer. We cannot certify batteries alone, but all the testing and all the qualifications will be met. And by this time next year, we should be certified in Europe, in EASA, and then a year from then into the United States. So we can start seeing these airplanes flying in the United States by mid-2027.
Hi, I'm Kristen Chern. I am the North American Sales Manager for H55. H55, as you may know by now, is the spin-off of the Solar Impulse project back from 2015. As a pilot, I'm super excited to be working amongst a deeply talented team. This is 30 years of genius behind electric propulsion that makes up the H55 power plant. With the Bristol B23 Enerique, this is our first partnership launching and proving interest in the US market and North America that there is a want for cleaner, quieter aviation. Our newer generation pilots are super jazzed about the new technology and all things that are electric. Cleaner, quieter again means that our airports and those airport communities can live in harmony. From my perspective, it's not only giving a lesser impact to the environment, it's a much more efficient training platform where you won't even have to wear headsets in the cockpit. So think about how much more dialogue and receptiveness there will be in a training environment. How much more of those clearer radio communications. That's one of the biggest hurdles for newer pilots to get past. As far as enjoying flight, an hour of clean, quiet, guilt-free environmental impact with this aircraft.
The interesting thing about H55's technology, the battery pack, it's modular. So this same technology, these same battery packs can be used in different types of applications. And the way you install it in parallel and series, think of like when we were kids, we had Lego blocks. You know, we'd move them around like this and like this. It really depends on the volumetric considerations, how much space we have, and what the airplane needs to be doing. The advantage of this is we don't have to redesign the whole battery module for each application. Okay, we have to customize it, but we don't have to redesign it. Meaning the cost for the manufacturer, for the customer, is less. Time to market is quicker. So it doesn't entail a complete redesign. So what other types of applications are we working on? Well, we have a project in Canada with Pratt & Whitney. It's a de Havilland Dash 8, 49-seat, hybrid electric, 30% savings on fuel for 49 seats. So that's really, we're moving the needle on sustainability here, and not just sustainability on the noise on the environmental side, but really on the economics. We also have a project with CAE and Piper to convert their fleet, the CAE training fleet in North America. It's up to 80 airplanes. The Pipers, they're taking an STC. They will be converting their fleet. Then they'll be offering that to Piper operators, and then Piper is obviously looking at a factory addition somewhere down the line. We have projects with operators. We have a project with Harbour Air in Canada. They operate seaplanes along up and down the coast, Pacific coast. They also have ambitions to be the first regional, fully sustainable airline. But it doesn't stop there. As battery density improves, we have other higher powered applications, larger airplanes. And then we start talking about the VTOL space, the flying taxis. This is where distributed propulsion gets very, very interesting. So there's all kinds of applications. We're looking at different type of hybrid configurations for bigger airplanes, dual motors. So all kinds of difference. So this is really the stepping stone. And this is why we started with the B23. We started with a relatively simple airplane. The technology exists. Certification path is clear. We know that they're cousins on the combustion side. They're older airplanes, they need to be replaced. Our pilots also, we need more pilots. We're flying much more since COVID. So this was a perfect application to start, to gain experience, to get the certification data, and from there we build up, okay? On our experience, on our data, on our knowledge, and we can move into, as technology improves, we can move into higher powered applications that have either longer range or longer endurance. In terms of the B23 Enerique, perfect airplane for flight schools. Flies 70 minutes, great for circuit training, has an hour charge time. So again, flight schools want airplanes up in the air. Standard automotive DC charging, so no extra special systems. Make it simple for adoption. In terms of flight schools not having to get special chargers, getting special authorizations from the FAA. So that's really where this particular airplane is targeted to these type of training, aero clubs, flight training centers. Even the military is looking at that for their first level.
Hi, I'm Marcus. I'm head of flight test and test pilot for H55. To look at the system of the electric airplane, we have two main batteries. One of them is in the left wing, the other one is in the right wing. So these two battery blocks are controlled by a battery monitoring system, and the power distribution is done by a big power distribution and control box. From there, we can apply power to the motor controller. The motor controller in our airplane is dual split, so we have redundancy from there on. And the motor itself is also consisting of two individual motors. And in case that one of the motor controller would fail, we still have enough power to climb safely. In the airplane, we have these battery modules that consist of 36 individual cells. You can maybe see them here. And they are stacked in one chain. Each of these batteries contains in the airplane 84 total batteries, so batteries, that's 43 batteries. We monitor voltage and temperature of each of these cells, And with that, we can detect failure very early. And also these modules are designed in a way that even if one cell has a thermal runaway, it will not ignite the next cells or go outside of this box. If this happens, you have to shut down one part of the battery. So you could disconnect one part, like the left or the right wing, and still have the maximum power, but you lose, obviously, capacity. The range of the airplane is 60 minutes plus 10 minutes reserve. And that should be enough to do flight training, where you have a typical lesson time of less than 1 hour. And the charge time after that flight is approximately 1 hour. So if you come back, you shut down the airplane and put it on the charger, do a debriefing with your student, have a coffee and brief with the next student, do a walk around, then you should be ready for the next flight. That typically takes about an hour. One of the characteristics of electric flight is that the weight doesn't change. So you have an airplane that has a fixed center of gravity and a weight for takeoff and landing. We are a little bit heavier than the combustion airplane. We have a lighter motor, but on the other side, the batteries are much heavier than fuel. And that leads to a slightly heavier airplane than the combustion version. My experience with that airplane goes down to the first prototype. So we are right flying the second prototype. With that prototype, last year we went to Aero Friedrichshafen from Sion, our home airport. That was the first time we've flown the airplane cross country. And what we also experienced in these flights when we take customer on board, they like very much that it's a quiet airplane. They like the experience being an electric airplane, and it's easy to talk and explain things. On the other side, it's very easy to fly because you have only a couple of switches. You don't need to do mech checks and other things. So it's also very easy to fly airplane. I'm looking forward to explain that airplane to a lot of customers, and we have very many flight schools that are interested in the airplane, and I'm looking forward to fly with a lot of flight instructors and get their opinion on the airplane.
Hi everyone, my name is Celine Bonnefous. I'm the lead flight test engineer for H55 in Switzerland. I joined the company 2.5 years ago, right after I graduated out from Georgia Tech Aerospace Master degree. And since then, I'm working, yes, as the lead flight test engineer on the B23 Enerique aircraft. So as a lead flight test engineer for H55, my role is to prepare all the test flights, but also the demo flights and all the activities, all the testing we do with our 2 prototype aircraft in Switzerland and also abroad here in the US. So from the first flight to the full envelope opening, performance phases, and then bringing passengers in the aircraft. I'm preparing all the routes, preparing all the tests, and then gathering all the data out of it, and then processing the data and doing some analysis and giving results for the engineers to improve our development. I'm lucky because in addition to my flight test engineer license, I'm also a private pilot. So it had a lot of advantages in my role, because I got a chance to understand everything that is going on in the cockpit, and also I'm flying also those aircraft for all the tests. Besides the test pilots, I'm guiding them through the test, but I'm also flying a little bit with them, and so I have the most flying hours actually on this prototype because I'm always up there with them. As a lead flight test engineer, I definitely have more time in an electric aircraft than on a combustion engine aircraft, because I did my lead flight test engineer course when I was already at H55, because H55 sponsored me for the training. So I went into that school. I did a lot of flying hours on different types of aircraft, many different aircraft. But then as soon as I graduated from the flight test school, I came back to H55 and started the real test campaigns with full envelope opening, performance phase, and then bringing passengers in the aircraft after that. I knew when I was doing my master's degree in aerospace that I wanted to be involved into electric aviation because my first engineering diploma is in electrical engineering. And then as a private pilot flying small aircraft, I wanted to mix the two and be electrical engineering on small aircraft. And I got the opportunity to join H55. And then they opened this flight test engineer position. So internally, I applied and I met Marcus, our test pilot and head of flight test. And he then introduced me to what's the lead flight test engineer role, and then they proposed to go through this flight test school, and I was lucky to go there, graduate from the flight test school. It was quite tough because I was 20 years younger than the average and the only woman in the course, but I made it. And then back at H55, I was able to use all this new knowledge I got from the school to our prototype aircraft. To me, the most interesting part of this aircraft is how quiet it is for people around, but also for people in the cockpit. I think it makes a lot of sense for people around the airport to accept those little aircraft in their vicinity because it's so much quieter than the combustion engine that it will improve a lot the environment and noise around the airports. And then of course the fact that it's fully electric makes a lot of sense to me as it's more sustainable, and even if we try in our daily life to improve the way we're spending energy and spending fuel, it's always nice to keep a little bit of fun, and flying is definitely a lot of fun, and we don't want to stop flying. We want to continue flying, but doing it in a more eco-friendly way, I would say. I'm really looking forward to flying more of these, especially in the flight schools, because I think that it's a nice use case. Basically, when you start your training, flying it myself, and I kind of realized how easy it is to learn in this small aircraft and to enjoy flying electric.
Today we fly the H55 electric airplane. The purpose of the flight is to introduce the airplane, and we will get to the airplane and explain the indications in the cockpit and then start for one traffic pattern. Okay, getting the B23 Enerique airplane ready for flight requires very little checks. We have one check where we check out our override system. So that system bypasses the throttle, and it has two power settings. One of them is for a cruise power setting. The other one is for max continuous power setting for a climb. And after we have checked that out, we are ready to fly. If you fly the B23 Enerique airplane, the power setting is done by kilowatt. So we have a direct kilowatt indication, and that is controlled by the throttle. There's only one control lever to set the power required, and we look at the kilowatt. Takeoff kilowatt setting in our airplane right now is 95 kilowatt, and for cruise we typically use 45, depending on the speed we want to fly. The first reaction that people have that have never flown an electric airplane is that the prop nearly stops when we taxi and we want to come to a stop. And then it's very quiet in the airplane during taxi and also during takeoff and flight. With that comes some interesting things that people have to get accustomed to change power. And the power setting is really done by the numbers, so you have to look at your instruments to adjust power setting. The other effect of an electric airplane is that it's very quiet in flight, so you don't need noise-canceling headsets. It's very pleasant to talk to each other, and it's a good training airplane in a training environment.
I had the once-in-a-lifetime opportunity to be the first flight instructor on this U.S. tour to fly the Bristol B23 Enerique aircraft. Taxiing out towards the runway at Vero Beach Airport, ATC kept asking for clarification on what exactly we were flying.
Hotel Bravo Sierra X-ray, Vero Beach ground. Can I get that aircraft type?
It's a Bristol 23 electric.
And Bristol 23, can I get that, what is it, like it is like an NG5 or something?
It's a Bristol 23 light sport that's electrically driven. You've never heard of it because it is a test prototype. Sierra X-ray Delta.
The first obvious thing to get acclimated to was all of the gauges monitoring the battery system. As Marcus briefed, we were looking for 90 kilowatts on takeoff and about 45 kilowatts on cruise. This was the first time I ever had to think about a kilowatt in flight. At idle, the prop didn't spin as fast as I'm used to in a combustion engine airplane. This electric aircraft was oddly quiet, so making radio calls and asking questions during the demo was simple and pleasant.
Sierra Beach Tower, Bristol, Hotel Bravo, Sierra X-Ray Delta, number 1 at 12 right, ready for takeoff.
Hotel Bravo, Sierra X-Ray Delta, Vero Beach Tower, make right traffic, runway 12 right, clear for takeoff.
Right traffic, clear for takeoff. Hotel Bravo, Sierra X-Ray Delta.
I quickly got used to the throttle on taxi and takeoff. Similar to a turbine, I had to add a touch of power and wait a second or two for the energy to spool up. Check out the climb power at 95 kilowatts. What a smooth, quiet, and fun ride. The B23 Enerique was easy to learn for a new flight instructor and really simplified the energy management so I could pay more attention to the busy airport environment.
Hotel Bravo, Sierra X-Ray Delta, River Tower, runway 12 right, clear, touch go, make right traffic.
I'd like to make this a full stop. Hotel Bravo, Sierra X-Ray Delta.
Hotel Bravo, Sierra X-Ray Delta, sorry about that, runway 12 right, clear to land.
Go to land 12 right, Sierra X-Ray Delta.
Feeling my way through the descent, adding some flaps, I eased back on the power a little too much, so to fix my altitude, I added a touch of throttle and waited another second or two. With a little more power, the aircraft was easy to land. No mixture, no carb heat, no noisy distractions. What an enjoyable way to be introduced to the future of flight with H55 electric power. Thank you for having me on this first US test flight.
I have to write down some numbers before I switch down everything. It was a super good flight. I loved it. It's a very busy airport, busy pattern, but yeah, we made it.
What are we doing in the United States? I mentioned before Across America. What's Across America? Well, Across America takes us from Florida, where we started at Sun and Fun a couple weeks ago. The next 2 weeks, we're flying all the way up to the coast. We'll be in Daytona, being welcomed by Embry-Riddle, which is a fantastic recognition for us. The foreign company being invited by such a prestigious university, and we'll be finishing in. We'll be going to Daytona, and we'll be finishing in that neighborhood. Then we'll be going to Alabama, where we'll be welcomed on a U.S. military Air Force base, to Phoenix, to Nevada, Las Vegas, to Palo Alto in California, to Wisconsin at Oshkosh, and then finishing off in East Hampton. So super pleasure. The last time I did this was in 2013, actually in 2016, when we did Across America. We came from Hawaii, we landed in San Francisco, and we crossed the United States up to New York and then flew over to Spain on the last set of legs. Why the United States? We've always had a fantastic welcoming and reception here. This is aviation innovation at its best. This is where general aviation is making its footprint, and a lot of interest from Americans, flight schools, from aero clubs, from the military, coming to Europe, trying out our airplane, and we said, no, the best way to do this is bring our airplane here. We've been here for about a month, and as I said before, the reception has just been fantastic, and we're standing in Faro Beach, and I'd like to thank our friends at Vero Beach for such a great reception, a great welcoming, and really enthusiasm and encouragement behind our project. The objectives is to really introduce, H55 is not so well known in the United States. We have American investors, but in terms of the aviation community, we're starting to get known. We're known from our legacy from Solar Impulse. The idea is to get known in the United States, to show our products. Obviously, we're interested in these airplanes being sold, but we're also thinking about where we'd like to establish ourselves in the United States. So this is a good chance to meet different state representatives and see what they have to offer. I have to say, Florida is on top of our list in terms of creating welcoming foreign companies such as ourselves and setting up. So that's another one of our objectives.
So please follow along on h55.ch. That is also our Instagram handle where you'll find the route. We have a site dedicated. It's across-usa.h55.ch. There you will find all the events that we're doing, opportunities to see this amazing technology in flight in the Bristol that I'm standing in front of. Come out to the airport, support. You can see it fly in, you can see us depart, you can meet the flight engineers. Also some of the founders from Solar Impulse are here with us along this tour. For those of you that are interested in being a pioneer, in accepting this technology with us, we actually have a founders round. We're calling it our Founders Pioneers. We have special rates and interesting package pricing for the first 20 that come along this journey and prove the market space with us, that there is interest in electric-powered flight. So come join the journey. This is a super exciting, innovative trip around the US all summer long. Again, kicking off here in Vero, but we will be wrapping up in August in East Hampton, New York. So please follow along at h55.ch.